Cool. Okay, I think we're ready to go. So first of all, a massive thank you, Matt, for coming along and sharing with us some quite exciting stuff, I guess. I've got to say, first of all, I mean, it's been amazing what the evolution on the 40% prints. I mean, you know, it's a small old box, and every time I think we've fitted everything that you possibly can fit into it, you go, hang on a minute, we've got to now put a little bit more in there. And you know, it seems to be a challenge to keep packing more in.
It keeps getting more and more distractions.
Yeah,
more and more challenges from the community, and people saying, I wonder, could you fit maybe? And then within probably like yourself, then within about a week or two, you're like, here's prototype A.
Absolutely. And the guilt that goes with it as well, thinking, actually, I can't make it compatible with everything else you printed. So guys, if you want the new stuff, you are going to have to reprint big chunks of this body. I did
actually learn from you in that aspect. I sort of saw some of the revisions you'd had of things and thought, when I design this, I'll try to plan ahead that I could do this, and this later. So when I know you were doing the full-size chopper, and I'd already had a chopper. He's in the background here. And then thought I'll do a mini chopper. That'll be fun to suit it, similar to the Eggbots that they've got, the 39%, the ALT 39.1%ers. So it's pretty much on par with that size. And then, but did plan ahead that I'd maybe try to tackle the 232 one day.
Yeah.
I didn't think I could fit it, but I managed to get it in there. It is a complex little build. There's one of the other builders in the group, Gary. He's been doing the beta testing for us in the background, and nothing major's come up, I don't think, but little quirks that come up that he's sort of given me feedback. Little things at the moment we're trying to resolve where I bought my servo MG995s from, he didn't get the same servo horns.
Yeah.
That was a variable I didn't think about in the worldwide community getting them. Are they all going to get the same servo horn? Because that was one of the key pivot point linkages that I've got for the mechanism for the tilt in the legs. So this is the body at the moment, the actual. So I'm driving it with the phone up at the moment because the intent that I had was that everything would run through that. So then when you hit the 232, it'll tilt the legs.
Yeah.
And then you hit the center leg and it'll come up.
Brilliant.
Center leg, 232. That's working pretty well. And then there's little things that people are given. The front arms will work off the app as well. So working with Gary, he suggested, because when you do up and down on the one of the right stick on the app, can you have it so that it does independent front arms? I'm like, yeah, okay, we can do that. And little things, I think Dan and one of the other guys sort of suggested about having little pieces insert as pieces rather than the whole print. So the version 1's great. It's very stable. This you can drive and then face plant when you have it in 2-leg mode. Trust me. I learned that from experience.
They are a little bit unstable in 2-leg, irrespective of whatever you design them at, really, unless you put really big things.
Every time you're a meter away from it and you still go to convert it from 232 mode, you still go,
no,
it's okay.
No. Well, that's the thing with big ones. You look at that, and you know, I've seen some magnificent engineered metal ones, and still they've got people that stand around trying to look cool, but you can see that glint in their eye that they're just terrified every time that transition goes, because he's not designed for real world physics, is R2D2.
No, top heavy, little tiny feet. Yeah, not a good combination.
Yeah. Cool. So what I thought would be really useful, actually, because I know we're releasing these on May the 4th, hopefully, fingers crossed, all documentation in place. But I think just be great to kind of get a bit of a view on it and have a look at the mechanism and the assembly, and you know, some of the gotchas as well. So as people kind of put it together, what they got to consider.
Yeah, all right. So I'll bring up the model that I've got currently. See how this all works and see if it's all good. You should be able to see that now. So this looks like a standard R2. So thank you to you, Michael, for sharing your files, because that's sort of the basis for the body and the dome. I think the legs I pretty much had to remodel entirely, and the center leg, just for different features that I needed on it. So I guess I learned a bit from the version 1, where this is broken into many pieces. So, and then adding the mechanisms within the legs, which we can sort of go into. But The dome's pretty much independent. I can hide that at this point because we don't really have to look at that yet. I'm still working on the mini dome with a periscope. So it's working. And then working with, like I said, the other builder, Gary, he's been working on verifying code for me, which has been good. Just having a second person to bounce it off is always a good thing. He can sort of test it before the whole gaggle of people get it. So the main operating linkages that are within it, there's a slider crank mechanism in the front for the center leg, and then just a levered crank in the back, which connects across the back here to connect both legs together. And then for R2 to stand up when he goes into 2-leg mode, there's a tie rod that runs from the top of the leg here fixed to the body and runs all the way down, but we can sort of explode that in one of the other views. So I think probably the easiest way, I won't sort of probably go into the front arm too much. I'll open that a little bit. So this has already been released anyway. So some of these are the same setups that's already existing that people have access to. So the front arm mechanism is two SG90 servos.
So people can get ahead and print that, can they?
Yeah, so this is the same as what I did for the other version 1. And then the principle of that is it's just a inverted sort of mechanism, similar to what you've done sort of on the larger full scale. So the only part needed is a bit of steel wire or a paper clip or something like that. And the rest of it's printed. The pins are all printed. It's just making sure, so these have got a small flat on the bottom that you print it sitting flat on, but it should all come in fine on the print bed. And then it's just checking, because these are getting quite small, one of the limitations is how fine can a FDM printer print it. So I've had to sort of make a few sacrifices here and there, so it's all solid within there. But that was trial and error, just getting some of that to work. And these will pivot in and out. But so long as you print it, check it's all loose before you sort of put it all together, and that it easily the mechanisms easily work, then shouldn't be a problem at all. So if we go back to sort of the main center lift, so the body itself is pretty much a hollow tube now to fit all this in. That was a bit of feedback, but also me printing one of them and not fitting my hand in the body. There's too much stuff in there. So I couldn't physically get my big mitt in there. I think I'm waiting for
you'd have to use small children to assemble it then, do you?
I'm waiting for my computer to catch up. I'll jump on this other drawing that we've got here. Oh, here's the center mechanism. So that's the center mechanism. So you pretty much assemble this whole unit outside of the body. There's 3 dovetail locations that locate into the body at the bottom. And this is the rear linkage that drives the leg main tilt mechanism that'll drive a servo arm up and down here. And then the front linkage is your bell crank, 4 rails. Learning from the periscope mechanism, I had dowels on that. And then I thought, hang on, I can just print hexes. I can lay flat on the bed, print, and then there's a perfect size, and everybody can repeat the process without buying dowels and acrylic rods and all those kind of things. So we learn as we do this and get better. So there's small things like inserted nuts, M4 nuts that go into here, captive nuts. I guess you could put a nylock in there and just lightly do that up. I haven't added bearings. I've just tried to keep it really simple. And the other thing I'm trying to do is, it's weighing about 2.5 kilos now. So the weight's actually added up quite a bit. So I'm trying to reduce the weight because it's quite chunky now.
How did the hexes slide? How would you find the hexes slide on plastic? Are they fairly smooth?
Oh, perfect. You saw it working just before. It works really well. It was a bit of trial and error, but it's worked pretty well. And it just gave an option where you can either screw them in with a couple of wood screws or a few other options like that. But like I said, just trying to keep it simple, and then it's accessible for everybody to get all the components or print them without having too many supplier issues worldwide, sort of thing. So this has got 3 socket head cap screws or M4 bolts, whatever the case, to put it in. Little things like the original caster wheels I did, it was sort of based on your design for Tito, I think it was.
Tito, yeah.
But then what I did was I realized that having the bearings in the wheel either side, which I originally did for cheap and mini chopper, it added too much weight because now I've got 2 idler wheels instead of 1 in the 3-leg mode. So I removed the bearings and just made this little plastic, just PLA printed 2 bearings in here, and then it works fine. There's another bolt that just goes in here to hold the leg on. Again, just make sure it's loose when you do it up so it can pivot easily. Little things where this is the front of the droid, and I realized when I drove it, if I went in reverse, the front foot wanted to kick up. In 3-leg mode. So I don't know how they do it on the big droids. I haven't made a full 232 on a large droid before. So these things, the cylinders, ankle cylinders, are just printed separately, and then just a couple of dowel locations with PLA. And then this is an ankle. This is a separate piece that just inserts into this lift mechanism part. So you can pretty much assemble the lift without the foot in it, get it all working, see how the mechanism works, and then it's pretty tight in the body because that's all got to squeeze in there. I've gone ahead and used, at the moment, I'm using just the MX 1508 motor drivers. You can replace these with whatever you want. It's really cheap. Being in Australia, sometimes it's hard for us to get stuff. Don't have the local supplies that you'd have probably in Europe or the US. I've just got a little voltage DC-DC converter, Arduino Nano, and a HC05 Bluetooth module.
That's one of the problems. The full-size one is just fitting the electronics and batteries in, and it's probably even worse on something this size. So.
Unless it's chopper, where it's just got this massive cavity, or
Yeah, exactly. All droids should be short, fat, and big.
We'll just design another one that's short and fat and big.
Exactly,
just another totally different one.
That's the great thing. You design your own. You can build it around the electronics and components, so it looks it's easy to assemble.
That's it. Once I started I had things driving off of the Arduino itself, and it started to get more and more complicated, and there was too many wire connections. So then I introduced the PCA 9685 servo motor driver sort of board. So this board here controls the 2 lift mechanism servos, the large ones. It controls the 2 front arms. And then from that, you piggyback off of this into the slip ring, which goes into the dome. And then in the dome, you have another one of these, and that's it. All the power supply, all the communication comes straight through with the 6-wire or 8-wire slip ring. There's some 6mm ones that, again, just working with Gary, just trying to find those at the moment, a good source. You can run a separate Arduino, a PCA 9685, and just a 5-volt battery supply. You can use, what are they? The little power banks that you get. I've got one else somewhere else. Just these little power banks you can buy from.
Oh, the USB
Officeworks, or just use those. So this is like a 2200 milliamp hour one. I had another small one somewhere, disappeared. So you can just run that in the dome, and on the PCA 9685s, you have this one as the standard one, and then you just have to give a signal A0. You just solder the pad to give it as the second location. So that's sort of, I've got that in the instructions as well. And then your daisy chain, but you need to send up the power through that as well. So this receives 4 lines from the Arduino, and all I did was at the top of this just put a connection and 2 JST connectors or something, so that you can slide this in. These are printed mounts just to fit all the electronics on. You literally can't have anything come out the back of this, otherwise it won't fit. That's how tight it is. So, and then where the mechanism slides, about 2.5 mil, I think.
Okay, still.
Just enough to hot glue everything on there. Yeah. So it's not too messy. And it's just a matter of just cable management. I can't really get, this is an 850 milliamp hour battery. I guess you could piggyback a couple, but people could come up with maybe clever solutions for where to put it. You could sit it on top of the servo if you wanted to put a bigger battery in, possibly. But that's sort of the main mechanism for the internal. That's the tricky bit for the inside, and just trying to squeeze all the electronics in there.
And where does the dome level come with the top of that servo? Is it much clearance or?
Not really. I'll just sort of section view in here. Let's see if we can get that. My computer can cope with us. It's not too bad, but it's not great either. But as you can imagine, it's getting pretty squishy in there. So
yeah.
Just sort of section it there. There's not a lot of room, but then you've got the lift, the other mechanism on top of that as well. So that's where you've got the crank in the back as well. So once you slide this into the body, and it was little things like that. So originally on the version 1 that I did, the skirt is a separate print as well. Now it's got 2 socketed cap screws that retain in the bottom of the base plate here at the body. I originally had it that it was screwed in from the inside down. I couldn't fit my big hands in there again. I went, so redesign. Just a little bit more plastic. That green arm is the main linkage pivot for the leg mechanism. So I'll bring that up in another image as well. So once that's sort of all installed, then the back door is separate as well. That just pops off. People can either hot glue it, or I've got a couple of small magnetic 5mm diameter magnets if they want. I've designed a little hinge in mine with a 6-bar linkage, I think. I don't know if you can see that on the screen here. So it works, but it's not great, and it's just really, really fiddly. But it's just a little hinge in there. People want to. I can put it up, but it's just pretty. Again, I need to get probably a resin printer. I'm getting too far on the limits of FDM printing. So that's kind of the summary of how that works. You put it all in with the back door off. You can get your fingers in there or your hands in there. You can attach the little M3 bolt in here to capture this, the M4 bolt in here. But you'd assemble all this crossbar linkage internally with the legs before you put the lift mechanism in.
Right, yeah. So
you can have it upside down and get your hand in from the bottom.
So effectively, it's a 2-part build, and you can separate it fairly easy, I guess, once you've assembled it.
Yeah, exactly. So that's where the dovetail is located in the bottom of the main body.
Yeah.
Prints upside down with no supports. And then you just push in the base or that center assembly. That all just shoves in there. 3 screws, and then 2 screws in here for the skirt to retain it in. And you can't actually see too much in there anyway, but I've got to compromise and sort of remind myself, well, this is pretty much a toy size. So when you look at a toy, there's screws sticking out everywhere.
Exactly.
So that's sort of the main internals. And then, like I said, hindsight, I would have made this hole on the original designs for the version 1s of these a little bit bigger, that suited sort of a 20mm slip ring or something like that. At the moment, I've got a 6mm hole that I can fit through. This is a 10mm diameter hole that is where the pivot is on the gear. There are, just one note, there are different geared motors of these yellow motors. There's a 120:1 ratio and a 101:48 ratio.
Okay.
I didn't realize that. I think Gary again pointed that out to me. So maybe just check. I had the 1:48. So I'd probably recommend those in. You could have them all the same, it doesn't matter. But if it seems a bit sluggish, maybe you've got the 1:120 ratio.
Did you get torque issues on the faster ones, or is it okay?
No, it's all fine. But again, those motor drivers, I think one of the other guys, so my background's mechanical engineering and fitter and turner. So I'm not an electronics guru. I'm all self-taught. So other guys in the group can, I think Ben, how do you pronounce his last name? Rees?
Ben Reed, yeah. Right.
And Trevor, there's a few guys in the group that are fantastic at electronics.
Yeah.
They offer little kits, so you can get in touch with them and purchase little kits from them, which is great. You've got your stuff on your website as well, little BLE boards. So there's options there that you can make this work whatever way you want. Me going down the path of a Bluetooth app, that was probably to allow people to do this without purchasing RC transmitters.
Yeah, absolutely. And also for gifts, if you want to make it for people to as a gift, then they're not going to buy the RC.
Yeah,
just anybody
exactly.
with
Then they can download the app, and then we can see that. Download the app, choose the drawer they want, and off they go.
Is that on iOS? You got iOS and Android, or just Android?
So it's Android at the moment. I wrote the app on MIT App Developer, which is free software, and this works great on Android. They've released an iOS version. I tried it; it didn't work yet.
Okay.
So there's hope. I don't want to have to redo all the code. It's quite a bit of code, but even that, it was me learning how to do debugging and code. Yeah, pretty much code debugging on phone apps, and why is this Bluetooth not connecting? And then my phone was hung up because I didn't have I guess when the Bluetooth doesn't connect or disconnects, what do I do? The phone didn't know what to do with itself. So just little things like that. But so this one here's the leg. The leg's printed flat on the bed. You can't print the leg with supports. Why? Because there's an internal cavity which allows you to run a little red bar in there, which is when our R2 stands up in 2-leg mode, he won't face plant.
Yeah.
That's the secret of the 232 bridge, which I know you worked on a bit yourself.
I did. The physics on the full size one, that bar takes a ridiculous amount of strain. And I tried printed ones, and I tried all sorts of different ways of getting it to be strong enough in a printed mode, and I just couldn't get it. Potentially a metal one might work, but it's the advantage of smaller ones. You're not quite got as much stresses on the physics side of things.
Yeah, this was a bit of, I guess it was trial and error. Got it on the first try, which is great. It stood up and it didn't face plant. So the only thing with this is there's a retaining bolt down the bottom, which is just an M4, again, a socketed cap screw, an M6 bolt, which is the main leg pivot. So there's the leg sort of here. It's the bottom of the leg that inserts. And then I've got these wedge-shaped pieces where it's got a mechanical physical stop as well. So that takes a bit of the stress out of that as well, where it presses against the leg. Again, just the DC motor, just a 3D printed Omni wheel. People can buy them if they want to, but I just 3D print it to make it easier. And then the battery box, again, it's just a cavity filler really for this aspect. Everything sort of sticks in the foot. Bolt down the bottom. Don't print the leg with supports because it'll print flat, and then that cavity will get filled in and it won't fit in there. The bar goes up through it.
It's not there, is it? It's impossible. Is it standard Omni wheel size?
Yeah, 50 mil. Yeah, I went with the standard size, so people do want to buy one, they can. I think I just downloaded an image somewhere that someone had dimensions on their page and reverse engineered it. You can buy one though, that's fine. Support the business. There's just some M3 retained nuts in here. And the only thing that's sort of tricky, this tie rod is the bit that actually, there's an M4 by 35 millimeter screw that goes from the body through the leg cat, through this hinge point here, because this top of this tie rod is fixed to the body. So it knows when it pivots that I want the ankle to be at 18 degrees or 0 degrees. So that's what it's controlling. So that's that secret bit of how does a 232 work? That's the linkage bit. But like you said, on a full size, it's incredible force in that, and it's got to be solid aluminium or steel.
I've seen some very clever gear mechanisms that in the leg itself that actually give it more strength, but I've never kind of got around to having a proper look.
Yeah, some guys, they'll have the gear mechanism at the top, and then they'll actually have a separate motor down here as well. But going this size, that's all I could really get away with. But I'm pretty happy it works. It has a little bit of a lean to the body slightly, just from, I guess, clearances on nuts and bolts and things when it stands up in 2-leg mode. But other than that, it's worked pretty well. So I've just done a rubber wheel lately.
Yeah, I saw that. Give it a bit of extra traction. That's
yeah, just got to the design from some crazy guy that did one of these. I don't know how he did it. But...
what you've got to do with those is you have to make the tolerances incredibly large, so it's really hard to put the rubber wheel on. Because I know the group quite like that. You have to put it in boiling water, which I believe that
I'll
guy
adjust
did.
It then, because I'll adjust it because that went on too easy. So yeah,
exactly. Okay. No, it's, I did learn that not all TPUs are the same with that, because mine went on quite easily, but nobody's lost the limit.
The other bit that will come out with this will be the assembly drawings that I do. So this is just sort of giving an overview of how it does look. There's just a bit of an exploder view, sort of detailing, here's a little sub-assembly, here's a sub-assembly, the leg's independent with the rod in it. So hopefully it's enough. It is a little complex build. There'll be lots of questions. Hopefully it's just the community can help with that. I think there's some really great guys that help out and try to answer as many questions as they can as well.
There is, yeah.
So that's sort of explaining just how the tie rod sort of mechanism works, where the bolts go. Just give a sectional view again of how it should look when you install it. And then again, this is that little sub-assembly. There's some little bolts that go in here 12 mil long. If they're too long, they'll stick out too far and they'll hit into the body. So just watch the length of the bolts that are suggested to use. That's just where the linkage mechanism attaches on that bar on the back onto the other servo that changes the leg position, which is this one here.
Mm-hmm.
So that silver part, the main crossbar, that'll be installed in the body. It's a bit of a shove to get it in there because you got to just deflect it a little bit to fit. And then the 3 bolts go in. That retaining bolt goes through there again, the M4 by 35, and that locks against the body and into that. He's kind of just with that tie rod. I actually just made that about an 3.5 millimeter diameter, and then just forced in an M4 bolt before I fitted it into the part. Little things like that, just to try to make it easier to then assemble. But just making sure before you assemble it that everything fits, it's loose where it needs to be loose, tight where it needs to be tight, just those kinds of things. So that's just
just go back one.
Loaded. Yep.
Yeah, that's obviously the prototype for the 2 to 3 to 2 bucket that you're going to do in the future, is it?
Bucket? Oh, yeah. There's even less room in him. Like,
hey, no,
I've got a full-size bucket. That's the full-size bucket.
Every time we do something, you then get the comments of, wouldn't it be great if you could?
So my son is my creative genius, by the way.
He's
the one that I started with an R2 center frame and then your printed dome. And then he's like, we went to an event. There was already 3 R2D2s there in Australia. There's not many builders, but it's a pretty good community still. And then he said, can we make chopper, Dad? And I said, yeah, okay. So we did a chopper based on all the scrambling of files that used to be there apart from before you got yours out.
Yeah.
And then last year he said, can we do bucket? Sure. So then we do a full-size bucket. And yeah, it's pretty cool. We haven't taken him to an event yet because of COVID.
I know.
Can't wait.
There's going to be a massive explosion of different droids at the next event.
It will be, absolutely. So looking forward to that. But so yeah, the Omni wheel, there's just an exploder view there. I think it's pretty, I hadn't seen yours actually before this, but I think it's pretty similar to what you've done anyway. As far as the assembly method. So just some little cut the wire, make sure, like with mine, I printed the hole on this wheel deliberately on size, and then I just drilled them out with a 2 millimeter drill bit. And that just guaranteed that the hole was round. And I just printed them in PLA, and they've worked fine. I did the same with the Sentry droid that I did. That was all everything was PLA. So, and then this was just a suggested sort of how you set up the electronics. There is another. I do have another. Oh, I've got the electronics one here. So that's sort of just where everything could fit. You can make it fit however you want to make it fit. It is limitation of size and where you can fit it in the body. So I'd suggest get it together, dry fit it, see how it works. If it's easy enough to get it apart, it's 5 screws to take the bottom out again. So it's not impossible. And then with the electronics, again, I'm not an electronics guy. I'm trying to just give the best I can. So apologies. I know, I think one of the last drawings I had the TX and the RX pins around. I'm like, oh no. And people were getting sort of mixed up. But so hopefully it sort of governs what the basics are. I'd suggest to people that don't work with Arduinos, just start with the blink sketches. Start with looking up how to connect a PCA 9685 to an Arduino. Get the servo motor to work off of that kind of thing. Do the basics first before you jump into this. But these are pretty handy little boards. Like you can expand that as much as you want. So this board here would cover the body for servos, and then straight up into the dome, like as I said, the slip ring here, and then this drives everything, and everything connect with the little servo wire cables, the jumper cables or whatever.
Yeah.
It just makes it easy as well for all the connections. You just can plug all these in. So you can drive LEDs off the PCA 9685s as well. So that's where with those, you just have the drive pin, which is the PWM and the ground, and that connects to the servo, the LEDs, sorry. And then like it says on here, well, servos, you just plug in the ground at PWM and that controls all your servo. So that's the hollows and the periscope. You can run this independently.
And resistors for those as well, haven't they, for the LEDs? Because I know on a normal LED, you put this 6 to 8 ohm resistor or whatever. But I think they're built into for them boards. Yeah,
that's right. So then that's that bit there where this is the one in the body, and you don't have this solder pad here for the. I can't remember. I think it's 40. It calls up in the PWM library, and then it calls up 41, and that's where it gets this. I think it's binary. I think it is. That's where you just solder across that pad. When this is connected with those 6 wires, that's what drives that one. So it seemed like a really simple way to do it. I've got just a little table here to say, well, what pin number is it in the body? What does it connect to? The front arm, the center leg, the body tilt. What pin number is it on this one? Remembering that it starts at pin 0. That catches me out still when I plug it in and go, why isn't that working? It's 0, 1, 2, 3. Yeah, okay. That runs all this, the dome lights, which are all just random blinking, the hollow servos, the rotational ones that I did, the little mini ones, the periscope up and down. So I've already planned ahead for that to happen. I'll probably add another one in here for the periscope lights to work as well. Because what I did with that was I made it, I'm trying to print it thin enough that it's transparent on the periscope.
Okay.
So when you put it in PLA, it's 0.8 millimeter, 2 walls on a 0.4 nozzle, but then it's transparent enough that it lets the light out with one LED in it.
Okay, I've always found natural. There's natural PLA and there's white PLA. If you get the natural, it's quite. It's
translucent.
Translucent, yeah. So.
Yeah. Okay, that's probably another option then. Yeah.
Yeah. It's worth getting. And
that's sort of the main part of sort of the build. I know there's going to be lots of questions. It's like I said, I've tried to make it as straightforward as I can. Not sure if it'll. I just know there'll be questions that'll come up, and that's fine.
No, it's cool.
Is there
any big gotchas on the electronics that you can foresee? Because that's normally where a lot of the questions come from. I know you've got
probably again the HCO5, just connecting this voltage divider. So what it wants to explain it to people, it's like the Arduino is running on 5-volt digital pin. So when it's putting out a signal, it's 5 volt, but the HCO5 doesn't want to receive that. It wants to receive 3.3 volts. So you've got a resistor here of 2K and 1K here. So as long as you connect this, that's what it is. I've put it in the code, a little cheat line where, I'll bring that up actually. There's a little line in here. So if someone soldered these in or wired these in the wrong way, you just note these out and swap it around.
Okay.
Preempting for people that have gone, oh, whoops, I connected it to the wrong one. It doesn't matter, but there's some limitations to what can happen in the code for different pins. These have to be PWM pins. I've kind of, again, maxed out what an Arduino Nano can do. So again, the other reason for possibly moving towards the ESP32 boards like you've done as well, just gives, it's Wi-Fi, it's Bluetooth, it's all built in. So it eliminates all the complexity of the circuit. But I can probably go through the code a little bit. There will just be some settings in here of what your maximum and minimum values are for your front arm. So how far does it open? How far does it close? If you're trying to pull it too low and it's driving the servo, you burn out the little servo motors. So just these variables people can change. I'd suggest start them at 50 or close to 90 each, and then just slowly just work your way, upload the code, redo it again.
It's like you said, really. I think that, rather than my advice has been the same, rather than jumping in and just blindly following the diagram and connecting everything up, grab an Arduino, grab a servo, grab a battery and just play with it so that you're familiar with how it works. Because when it comes to tweaking code and fine tuning, it's a godsend if you actually understand the basics as opposed to just, trying to follow the instructions without having that understanding in the first instance.
Yeah, exactly. There's a lot of satisfaction in doing it yourself as well. You can do it really cheap. I've tried to design these to be cheap. That the electronics are cheap, that yes, you can spend a lot of money, but I think people want to spend a lot of money on their big droids, and keep the small ones pretty cheap. And yeah, a couple of rolls of filament, or not even that, and cheap electronics, and off you go, have a bit of fun. Then if your kids drive it off the table, you're not going to cry too much.
No, exactly. You can print
hundreds. Yeah, so I guess the other bit that's sort of in here would probably be, I write my code as functions. So this is where all the periscope motion works. This is where all LED 1 is working. And then when it calls that up in the, so basics of the code, which I know you've gone through as well, you've got just all the things I'll call in, all the variables, and then you got your setup. This is where it's calling all the setup functions. There's a bit of maths in here because the PCA 9685s run on Pulse, I think they are. Yeah. And then you got to convert it. So it does all the maths for you. But defining all the pins, and these are the functions that it's calling up. It just means that my loop is really short. So it doesn't get messy. And then you can go, okay, I want to change the time on LED 1. Where is that? And you just got to find LED 1 as a function name. So I try to do it that way to hopefully make it easier for other people to find it. And then this bit here, if you plug in or you want to change one of the pin numbers on those PCA 9685 boards, you just change it in here and call it up in the code again. So let's say you hollow LED 3, you want to change how fast it's blinking or which pin it's on, you just change that number there and then change it down here to the same one. And then when it connects to the phone app, this is what it's spitting out in the code. So it's trying to tell you what variable number 1 is, number 2, number 3, number 4. So 1 and 2 are your drive. So you should see you're getting a value between 0 and 255 for the pulse width modulation. 3 and 4 is the up and down and left and right. So 3 is the dome spin, and 4 is the front arm up and front arm down, but that's doing the two different ones. So one down on the app will open one arm, up on the app will open the other arm, just to keep them independent. Again, good just working with someone else, Gary, just to get a bit of feedback. And he's like, what if we did this? So, yeah, that's a good idea. That's the lift mechanism, the tilt mechanism, the periscope. And then the sound one, for people that use the app, when you press a button, I'm trying to get this right. If that's pressing that button, it's calling up number 1, right? Or it sends a signal number 1. So if people are clever and they can code, they can come in here and where's it got the sound? Not sure if I have it in here. I don't think I have it in this one yet. So my intent was that if you call sound number 1 and it's a scream, you could have all the lights blink and do whatever you want to do with them.
Yeah.
So you could start to incorporate that kind of stuff. Like there's a few, is it Curious Mark? What's
Curious Mark,
Yeah, so he's got his R2 app that he's got, which a lot of people use for their droids, which is great because you've got page and page of buttons you can press. So I tried to sort of think ahead for that kind of versatility a little bit. But hopefully it's sort of pretty straightforward. Yeah, I don't know. Is there any other questions you got on other stuff or?
No, that's cool. That's cool. So, but yeah, I mean, just let's have a look at the one you've got. Is it powered up? The one you've got just shows a 2-to-3-to-2 mechanism.
Yep. Oh, the desk isn't big enough to go back.
Okay, yeah.
So that's me pressing the 232 on the phone app.
Yeah.
There was a bit of stuff in around trying to do the. I think I talked to you a little bit about the delays I was getting on some of the serial software.
Yeah,
there was another library that I found, a Neo software serial. So just lots of developing of the app and trying to get things to do what they should do. So this is up and down on those 2 servo arms just to keep those separate. Again, that's just coming off the phone app, dome rotation, and then on the app I sort of customized it a bit to make. You can stick there's room in there as well to put a 40 millimeter speaker. So you can go buy this is a $10 speaker that I got from Kmart, I think.
Yeah.
Okay, Kmart. Do you have Kmart?
No, I've heard of it, but we don't have it.
Just like a multi-purpose shop. They sell clothes and other random stuff. Yeah, so that connects. Yeah, this connects via Bluetooth.
Yeah.
So I could just stuff that in the body if I wanted to, have that receiver Bluetooth. So you can connect your phone app outside of that to a Bluetooth speaker, and then still connect this to HC05 as well. And then when you press play on the sound, it'll play the sound. Yeah,
so that's literally just like an external Bluetooth speaker then, rather than anything complex.
Yeah, it just means that everything's driven off of the app. So once you then sort of start using the app, and then I've got the option in there for all the mini droids that I've done apart from the Sentry droid. And then I was stuck in your mouse droid as well. If people want to hack it and use it for that, they can use the code. Yeah, but it was a good challenge to write the phone app. I think it's worked pretty well. There's been a few limitations, but it's just getting better and better and get over some of the hiccups. But yeah, no, it's been enjoyable. So great community to be a part of. So yeah.
Yeah, no, it is a brilliant group. As you said, it's the mixed skill sets that we've got. We've got, Trevor and Ben who do all the electronics, and then, and the community as a whole kind of keep challenging us to do more and more cool and exciting stuff. So.
I don't think you don't need any more prompting. You just do more.
Exactly. Well, it's nice. It's just pushed 3D printing and these models further and further forward, which is so cool. So what's next? Are you working boosters on the side so it flies?
I had thought about not on this one. No. I don't know what's next. I think I thought about doing another challenge. So I was thinking of doing like a mini gonk droid that could walk.
Yeah.
I was going to reverse engineer. My son's got one of a small BB-8, but reverse engineer that design and the mechanism to make a mini one to suit this scale as well. Again, just Bluetooth control app, just have it on that so people can drive it around again if they want to. It'd be pretty simple. It'd just be the ball rolling and the head stuck on with some magnets, just for a bit of fun. Yeah, that's sort of about it at this stage. I've got to get back onto my full-size build. I haven't finished that yet, so
you've got to get them ready for the opening as the world starts to open up again, and we can actually take them out.
Like I said, I've still got 2 droids to take still, so I've still got to take that chopper and bucket out again, so that'll be good fun.
They've not been out yet, have they?
Chopper has. He's been pretty good at events, but then it sort of stopped, and then just waiting to get out again and take bucket out, and it'll be good because that'll be the first time that my son and I could actually take a droid out each. Because because it's just been having the one taking chopper to the events, but that's been good because the other builders have got some R2s here, and there's an R5 now in Australia, in Melbourne, where I am. Daniel's got all these crazy, he's doing an ALT and 10 other things. Just a bit where you don't tell anybody, or the wife at least. Don't ask about the filament. You don't want to know.
Well, it's easy to sneak 1 kilo rolls in every couple of weeks, isn't it? So we're okay with that. But no, you've got the great community actually in Australia, or they seem to be, and it's sort of punching well above your weight in not volume, not a lot of people, but what you do is incredible, really. Yeah,
it's good. Like we try to catch up when we can, but like we say, we've sort of been in the same boat as a lot of other countries with all the COVID. Melbourne sort of went into lockdown for 6-9 months or something. I can't remember how long it was, but it was a long time. And sort of that finished. So I ducked out and saw one of the guys, and we're just hanging out again for a day, just chatting. Not really much building got done, but just hanging out.
Exactly.
But yeah, cool. I love that it's a worldwide community, and I've had sort of guys, Colin in Canada, he's done some tests for me, some test prints, and Stephen, south of France. Like my kids are like, "Who are you talking to today, Dad? And where are they? Where are they in the world?" And that's one of the great parts about it. So why I love sort of give away sort of the designs I have and just be part of the community. I sort of mentioned to you about I don't want to start something else. I just want to be part of this and have a bit of fun. And people are really generous. Every now and again, some people will buy me a coffee, so I appreciate that. And keeps my wife happy, pays for more filament, keeps another droid coming. Yeah, so it's really good.
I think we'll hopefully when the world does open up, we all get to meet together. There's going to be quite a few parties, and I don't think you'll be buying much of your own beer on them evenings. So
that'll be really good. Yeah.
Yeah, I know. It'd be nice to get together and just to get to see each other. Cool. Well, massive thank you for everything you do on the community. I know, you know, the minis are just incredible, and they're a really good on-ramp to people who want to build the bigger ones and just get their head around electronics and all that kind of learning stuff. And it's also the time that you take personally to help people and support people through that. So a big thank you, Matt. So, and May the 4th is the due date for the 2 to 3 to 2.
It'll be there. They'll open
there.
up one day, and then you can release the announcement and say mini droid 232 available, and it'll be in the folders. I've already got the folder structure set up. I'm just going to get all the files in there, and yeah.
Very cool.
I'll wait till May the 4th. Otherwise, I'll grab it the day before.
Yeah. As you know, I can't
savage.
wait.
They're savage. They're just asking before you've even finished it.
They're just hitting there. They got the open folders. Just hit refresh until something appears. Cool. Right. Thank you so much, Matt. Good evening. Have a great evening. It's 10 o'clock there now, I think, isn't something like that around that?
It is. Yeah, that's the time difference bit. You have these drinks and droids, and it's too early for me, but I'll still get on there sometimes.
No, well, I know if you kind of wake up bug-eyed at 6 o'clock in the morning and go, oh, hello.
You're drinking drinks. I'm drinking coffee. I'm like, what am I doing here?
Exactly. Look, Australians can drink at any time during the day.
That is true. Yeah. Sorry. Yeah.
Exactly. Cool. Okay. Cheers, Matt.
Thanks, Michael.
Thank you so much for that.